Well, that didn't work. I scheduled to start at 4 o'clock and could not find anywhere to start the live stream. So I hope you find this new stream. I had to set up a whole new one. So if anybody gets the alert and comes on board here, we'll start with what we were going to do in the scheduled video. So I'm hoping you can come back and check it out because I did have a few people online there. See, there's 3 up there now. Technology and me aren't getting along very well these last few days, but we're going to give this a try anyway. And I also would like to apologize for the other false start. So this is now 3 of them. One of them I was successful in doing a quick little test video of about 3 or 4 minutes. That was at 1:30 this afternoon. That worked. This one didn't. So I'm not sure if you need to have encoding software. I do not believe so because I did it earlier, and I think you can just go live with your webcam as I'm doing now. But the scheduling seems to be giving me some kind of issues. So, like I said, I'm not if it starts automatically when you schedule it, or if you need to hit go live. But when I hit go live, then it asks to connect it to the encoding software, which I have not downloaded. And I don't know why it worked at 1:30, but it worked. It's working now. I'm sure I lost a few with the ones waiting for the scheduled one. Anyhow, just wanted to try this out. Just wanted to try going live stream out to see if I can possibly help people that maybe can't or are reluctant to get an electrician in to help them with any of their problems, or maybe the electricians or contractors aren't even allowed to work in these crazy times. So I thought I'd try to see if it works here, and if it's helpful to you, we'll do it again, and we'll possibly try to get it working a little better and a little smoother than it has been so far. I see we have some questions coming in, so that's great. And we'll get to these in a bit. I just wanted to start out a little bit slower here and a little bit more casual and see if we can get some more viewers online. I see we've got 14 as of now. So while we're waiting for more to join in, we'll keep track of these questions. And let's just talk a little bit about where everybody was when the world stopped turning, or in us in particular. We were in Costa Rica. We were supposed to be there till the end of March. And then, of course, everything started rapidly deteriorating in March, and flights were being canceled. We were scheduled out April 1st. And Sandy got a little bit panicky. We had a cat down there, and we needed to get back to Arizona. We had some business to take care of there before we came back to Canada. So she was able to grab onto a flight on March 19th, I believe it was. And then I stayed on till the 25th. I actually caught the last flight out of there on United that took me to Houston. And then I transited over to Arizona, where Sandy and I again met up, took care of that business. And then we drove back to Canada. We just got here actually 1 week ago today. So we're in day 7 of our little quarantine here in our place in British Columbia. And I see we got about 16 people on there right now. So I'll get to the little demo we were going to do for you here. And that kind of revolved around a video I did. It's a fairly popular one on my channel, but I got a lot of comments, or a few comments, not a lot. Most are good likes and positive, but a few saying you didn't show where the open neutral was. And my comment back was, I didn't think I needed to show 2 wires not connected together, but nonetheless, we'll go through it again here quickly because it is kind of interesting when this happens, and it's a common problem you'll find throughout the house. So I'm going to show all that. What I'm going to do is just adjust the camera here, and I'm going to kind of do a demonstration for you. So bear with me. This could be a little clumsy, but we'll give it a try. So I've set up a little demonstration of this whole scenario here. And as you can see, I've got my power coming into this 3-gang box. Now this wire here, cable, is the power coming in. And you can see it is spliced, pigtailed, 1 hot wire over to the switch here, and the other hot wire to the receptacle. Neutral's pigtailed as well, just to the receptacle, and patching it on through to the light. And of course, I got my ground wires connected here. They enter the box. They go around one ground screw terminal. I looped it around there, tightened that screw down, then up to a splice here where I pigtailed a tail off to the receptacle, which you can see on the back here. Careful not to give myself a shock, because that would make it quite amusing to get a shock on live stream. But it might really add to the viewers, so we'll see what we can do. No, actually, we'll be safety first when I go work on this a little more. I'm going to unplug it to make the changes. But there's that ground pigtail to the switch. And then on the top of the switch is the hot wire going out to this light. So let's do some testing. As you can see, I've got my plug tester in here. And those two amber lights on the right side tell me that it's wired correctly. There's a little schedule on this plug tester that tells you that. I don't think we'll be able to get a tight enough shot to see that. That tells me this whole circuit is wired correctly. So power going into one side, side of the switch, excuse me, turn it on, flows out of that terminal, off to the light itself on the hot wire there, and then comes back on the neutral. So if everything's normal and working, this is great. I'll show you the readings you can expect. Turn that camera a little bit towards the meter. Turn on my meter to volts AC. Try to get it out of the better view of the screen there. Okay, so connecting to the neutral. I'll pick that off with the common lead here. Pick off this neutral right on the light. Incoming power on the receptacle. You should see around 120 volts there. 118, 17 we got. And as well on the hot side of this switch with the switch off. One side of the switch will be hot. There's 120 volts. The other side is not. So we turn that on. And the voltage is, and the current now is flowing through to this light bulb. Checking the light bulb, the hot terminal on it. And we have that 117 or 18 volts. So what happens if you lose your neutral in this case? So normally, now neutral, testing from neutral to ground, we should have basically 0 volts. And we do. We have a little bit there, millivolts, maybe of 1 or so. So we have 0, that's what you should expect to see. Now I can touch a ground wire because that's just an earth ground. And actually I can touch that neutral because they're bonded at the panel. So there should be no potential difference between the neutral and the ground. And I wouldn't get a shock by touching that, but I don't want to set a bad example here by doing that, because as I'm going to show you, if your neutral becomes open somewhere else in the circuit, that neutral is no longer tied to ground. It's actually floating and open. And there's going to be a full source voltage on that neutral wire. So let's do that. I'm going to just unplug it for now. And I'll show you where I'm feeding. I'm feeding this circuit just through a plug-in right now and through this little junction box. So let's say something happened towards the panel from this circuit. Everything was running normally, then suddenly something happened. This neutral connection came apart. So we're no longer connected to the neutral bus bar in the panel. Let's cap that off now on the source side. So the next day, let's restore the power here, which I'm doing. Normally you turn on the breaker, but I'm just going to plug it back in now. Wow, look at my plug tester here. I see the red light is lit and the amber light on the right. And when you look at the schedule, that tells you you have an open neutral. A hot ground reverse is what it says on here. That should say open neutral. So regardless, here is a fault in the circuit. And you know that you've got a problem because you go turn on the light switch. And of course, the light doesn't light. So how this whole thing started was a buddy of mine. He emailed me and said he was working on his own home and he was going to hook back up, say, a circuit like this, and the light didn't work as it doesn't here. So he was touching the neutral and he got a shock. So he texted me, he said, how can I have 120 volts on a neutral? Well, here you have it. This is why. You can see the neutrals are apart here. So let's do some testing again. Now we'll have to do it to ground. So I'm going to hook my common lead onto the ground wire. Oh, by the way, here's another question I get a lot of times. People say, what's an electrician doing working with rings on his fingers? And you really shouldn't. So I'm going to play it safe and take those off. But normally, if you know what you do, the guys that don't have fingers, they're the ones that weren't careful and they had rings on. But yeah, as you can see, I've been doing this for about 40 years. All my fingers are intact. But anyhow, good idea. Take off those rings when you're working on electricity. So let's check now with the meter. We got the common on the ground. And checking the hot side here. We got about 100, what do we got? 120 volts. So check the switch again, 120 volts on the one side, the hot side. That's with it off. Now, it off, nothing on that side. Turn it on. Well, 120 volts here too. Why isn't my light working? So go to the light. Check that light out. And check the hot, 120 volts. Check that neutral now. Got 120 volts. Did you lose the video signal? Apparently we've lost the video signal. I've got Sandy watching in the office here. Now, I'll just wait to see if it comes back. Can somebody let me know there on the text or the chat box if they see the video? It's still working, says Ken Pryor. Okay, thanks, Ken. Not sure what happened there. So there we go, 120 now on a neutral. And as I discussed, we should not have any voltage on that neutral. Let's turn that meter so you can see that. So explain how this happens. Well, you've got power, you've got the supply, 120 volts coming through the switch, through the light. Now, inside this light bulb and with any resistive or any kind of a load, you actually have current flow through the load. And in this case, it's a light bulb, an old incandescent light bulb. So it's flowing. 120 volts is coming out to one of these prongs inside the bulb. It's going inside the lamp. It's going through the filament, the tungsten filament, returning on the neutral. But with no path to complete the circuit, all you're seeing now is that 120 volt flowing through that filament and on the neutral. And it has nowhere to go, so it's hot. If I touch that now and touch ground, I'm going to get a shock. So when you connect back up the neutral, everything in the circuit will again function normally. So let's do that. Unplug it again so I don't get a shock on live stream. And I'm sure a lot of you are waiting for that to happen. Okay, I've connected my neutral back up, as you can see here in the junction box, bringing the power in. Plug it in. And there we go. Our device tester, plug tester is showing correct wiring now. Turn on that switch, and my light bulb lights up again. All is well. Check the voltages, of course, just to be sure. And we have ground to hot. Around that 119, 120 volts. Same with over here. And everything is working fine. So I hope that helps explain a little bit better, and now actually showing you that where these two white wires were apart can help you understand how you get that loaded neutral. Now, why would that happen? Could be in the case of my buddy that texted me about this or wrote me about it. He had been working on that circuit, and he had taken that all apart and he forgot about it. So when he powered it back up, he didn't realize he had a whole junction box opened up and the splices apart. But this could happen with a staple, maybe when in construction was nailed too tight on these cables against the stud. We're going to imagine that this is all on the wall. So a staple may be too tight, and finally over the years that wire burned off, so that open newt up. Many times you'll see that electricians use, or do-it-yourselfers use, the feed-through screws. They might have, instead of just one neutral coming in here, they may have the outgoing neutral to another device connected here. And that can be a source of the problem. If those terminations weren't done correctly and nice and tight, that can cause it. And later, also, they could have broken the tab between these two, so that could break your neutral. And just a poor splice, like if somebody didn't do this splice correctly and one of the wires was pushed out of the wire nut, eventually it burned off, that would give you the open neutral. Or bad termination right at the panel where that circuit originates. If that screw wasn't tightened down properly, that could also cause an open neutral. So there you go. I think we've got now on board about 20 people, and we've got some questions to get to. So first off, just does anybody think that if this is a useful tool that you think you might use in the future, we'll continue doing it. But right now we're going to go probably for a half an hour at least, maybe 45 minutes, just depending on how the interest level is. So let's look at a few of the questions. Say Ken Pryor says he'd like to see me do this again. So what I was talking about doing is every Wednesday doing what's called Wiring Wednesdays, and we'll try to schedule a consistent time to do a live stream like this. Somebody asked to turn the multimeter more towards the camera. I hope I caught that in time and you were able to see it. Now I'm going to scroll up a little bit. I had some earlier questions. And we'll take one of them and answer it. So this guy, N6 Yun, says, using a multimeter, how do you tell which wire is neutral and which side is hot? Well, generally your colors should be brass or copper for ground or green. White should be neutral. Black, red, and sometimes blue are your hot wires. Now that doesn't mean that people always follow those rules. I've traveled in enough third world countries to know that don't trust that, because a lot of that wiring there is done in concrete and block and just conduit, and sometimes it's just not available, all the colors for pulling in different colored conductors, and you will find any color used for anything. Green's used for hot, vice versa, white used for ground, black used for ground, white for hot, so you can't trust that. So how do you know? So as I sort of demonstrated with that open neutral, if you're looking on a circuit that's working and you can't figure out which one is the neutral with your multimeter, using a multimeter, I should say, connect the common to ground and then check with your other lead to one of the terminals or one of the wires, and the one that's hot will be 120 or close to it volts to ground, and the neutral should show basically 0 volts to the ground if things are done properly. So that being a properly grounded circuit, that's how you would tell. Let's see if we have any other questions here in particular. Hello from California. Hi from British Columbia on Vancouver Island. This is where we are. Yeah, watch out for the murder hornets. Another interesting thing being thrown at us now, as if we didn't have enough to deal with. That's also up in Washington. See, there's been sightings of them there and in Canada. Yes, USA as well. So the feed is still working. Here's a question whether this is going to be uploaded to watch later for future reference. Yes, these get saved and they'll be in my video stream. As well as I'm going to embed the original video I posted about the loaded and open neutral. I'll put that in the description here, and it can be linked to, and watch this and link to that video later. So does anybody else have a question? I'm looking at the text box, chat box here. I'm not seeing any other particular questions. Is anybody having some issue in their place? I can go to one little question I answered here just recently from one of my clients or viewers. He was asking some questions about how to wire in a generator permanently into his outbuilding. He basically had a generator in one, or outside in a vented building, and then he had a bathroom, washroom on the other side of the wall, and instead of running cords out to the generator, he wanted to wire that in the wall. And so he was asking if he could just put a receptacle on the generator side of the wall and then run his circuit to his light and another receptacle in the bathroom, and then from the generator just make a two-ended extension cord with males on both ends. And I said, no. That's one of the reasons that it's very, very important that when you're connecting in temporary power or backup generator into a system, that you do it right. And then if you're not going to do it right, I really don't recommend anybody tackling this on their own. You need to properly tie these in a permanent way using a transfer switch, or having something that is a device that you just plug in and you simply unplug it from your home where the power's out and go plug it into the generator and make it work that way. Otherwise, you got to have a transfer switch, either a transfer safety switch or a transfer switch panel that you pick some circuits to put on. But anyway, back to that double-ended cord. There is a way you can do it, but you don't use a cord with two male ends on it. I told him about a flanged inlet, and he had never seen one of those. And what they are, I've got a old dirty one here, but what it is it's a fitting like this. And this one, this is in particular, is a 15 amp, 120 volt locking one, but they could be a standard device receptacle, a blade receptacle, 120, 15 amp, 120 volt as well. So this fits into a box, and it's surface mounted inside the box. So your terminals, when there's no power here, this is feeding into your circuit. So these aren't live. Whereas if you had an extension cord, double-ended, once you plug one end into the generator, the other end is going to be sitting here with live conductors on it. So what you want to do is have a flanged inlet, which is basically a male fitting that fits into a box. This end would get plugged into the generator. This is in the box to feed everything. And now you've got a female end. And like I say, just this is a locking connector, but it'd be the same for a regular one. So you got a female here that if it's hot, you're not going to come into contact with live parts. And then you insert that into the flanged inlet, and that powers up the circuit that you were trying to power up with the generator. So if you happen to be here, the guy that asked that question, that's what a flanged inlet looks like. And they come in many ways, shapes and forms, and weatherproof and non-weatherproof, etc. So here's a question from DBLR616. Says, I found an open neutral in my garage. Burned up a few items along the way. Most notable was a circuit board for the cooling fan on my welder and the power supply to the furnace. Yes. Generally, there might have been something else going on there, because generally a loaded open neutral will just make things not work unless you accidentally shorted that out through something else to take out that circuit board. But yeah, it can cause all kinds of problems, as well as an open neutral in a in your main panel or inside your meter socket. That can cause a lot of problems as well, because without getting too technical, you've got 120 volts on each leg and you've got a neutral. So a lot of your devices and things in your home take 120 volts. So they take one leg or the other, connected to neutral, gives you 120 volts. Then you have your 240 volt appliances that take a hot from each side, and always a ground and sometimes a neutral. Like your stove has a neutral and two hots and a ground. So you lose that neutral, and that can cause you to have all kinds of floating voltages there, because now there's no more center connection that keeps everything balanced, and 120 between them and 120 between hots and neutrals and the 240. So without that neutral, those voltages can float all over the place, and you can get anywhere from 220 or 240 volts on a 120 volt appliance. Anywhere from, depending on what else is on in the circuit and where the problem is, you could have anywhere from 240 down to 0 volts and anywhere in between with the broken neutral. So a bad thing, a broken neutral. Also talking about that a little bit, I get a lot of questions about people saying that part of their home is gone. The power's not on, and it seems like half the home is off. And yet, lo and behold, they'll turn on their stove top or their oven, and the other half of the home that wasn't working now starts working at a reduced voltage. So what that is a broken hot wire somewhere in the system, usually on the mains, either the main breaker or in your meter socket, or maybe even at the street, at the transformer. And what happens then, now you've only got one of those legs coming in, and it can feed through. This one's broken. Now you turn on your oven, and it'll feed through the element, much like we showed with this light bulb here, flowing through the element or the filament. It'll flow and backfeed the leg that's lost its source, and then things can come on at a reduced voltage because it's running already through the resistance of that element. But getting a little technical there, always good to have your panel and your whole system checked out. Maybe once a year or every couple of years, have an electrician come in and retorque all your connections and do some testing with the multimeter to make sure you've got all the good readings. Okay, so Craig Moon says, enjoyed it. Wiring Wednesday sounds great. I think we will probably give this a try again for sure. Now, Ken says, I recently heard of a transfer switch that sort of goes in between the meter and the meter base. Yes, that's correct. You remove the meter, the device snaps in the base, and the meter goes into it. No, okay. I haven't heard of one that plugs right into the meter base like that. I'll have to look into that. And then the add-on device has an outlet to connect the generator to. Well, good. I'll have to look into that, Ken. Thanks for that. So if anybody else has some questions, we'll get them in here. And if not, we'll wrap this up and we will try to be a little more polished and a little better prepared, figure out the technology. I'm going to have to get one of my nieces or nephews to get their children in here and try to help me figure out the technology because I had this all lined up to go live. And when it came time to do it, I hit the wrong button, I guess, and lost it. So anyway, thanks for the people that did tune in here. I see we got 14 online now. Appreciate that. Appreciate you sticking with me. And oh, there's someone saying okay, yeah, Pro answers. He's asking Ken if that device would protect backfeeding into the grid. Yes, I can answer that for Ken. I'm sure it would, or they wouldn't build a device like that because that's the primary concern is you have to have either the utility feeding your house or you need the generator feeding it, and you cannot have both at the same time. So that's the idea of a transfer switch or this device that Ken is talking about here. Here's a good question, actually. I want to answer this one. Can the idiot ticker device be trusted to detect power? Well, I have one of those here, and short answer to that is no, because they will pick up. It's a good device just to have to kind of check to make sure you got power or not. Now, there you go. I'm going to turn the camera down again to this circuit I've got going here. On the hot wire. Yeah, my little ticker device is ticking away here, but kind of not that trustworthy because it's ticking, it's detecting energy just in the air around it. And another issue with them is you can even use it, it'll even detect some static electricity by rubbing it on your head. So these aren't that reliable, but they do kind of give you an indication if there's power there or not, because let's just check. I'll unplug it again. And no beeping. So no power. Let's go down again and show you. No power here on the circuit, no beeping, but still a little bit of brain waves coming out of here, which is encouraging because I thought it was going to explode when we couldn't get the live stream to work. Okay, is there any other questions here? Richard, thanks for Ricardo Cintron, thank you for this, and thank you for tuning in, Ricardo. Thanks, Craig. Thanks, N6 Yun. And anybody else that tuned in? We're down to about 11 now, so I think we'll wrap it up for today. With the format, I think I'll try to do again some kind of a little educational component and just open it up again for questions. So keep them in mind for next Wednesday. We'll try to do it again. Let me know in the comments if there's a better time you'd like to see, maybe later in the evening, maybe midday. Guess it depends if you're allowed to go to work or not with all the COVID action happening around the world. So stay safe, stay healthy, everybody. Follow the rules. Let's get through this, but let's also get back to work because we need that. We don't need the economic harm to be any worse than it already is. So if we can go back to work, let's do it safely, do it with the proper procedures in place and keep everybody safe and protect the ones that are most vulnerable. So everybody, thanks again for tuning in. I'm Terry Peterman, the Internet Electrician. And don't forget to go onto my YouTube channel, like and subscribe, and click that notification bell. I've got lots of videos up there and lots more to come. So thanks again from Terry, Internet Electrician at electrical-online.com, right here on YouTube. And Facebook is facebook.com/Internet Electrician. Thanks again. Don't be afraid to shoot me questions on any of those mediums. We'll talk again.